Welcome back everyone to part 3 of this series. In this part I have a lot of cool stuff planned for you. We're going to learn how to properly implement the shooting arrow functionality by first pulling the bow and holding it before firing. And depending on how long you pull the bow for and how long you hold it, this will impact the speed and the gravity. And we're going to add aim offset animations to make our mesh look towards where we're aiming with the camera. And we're going to be also adding a crosshair widget to see where we're aiming. And finally, we are going to correctly calculate the direction of the arrow to go exactly to the center of the screen. So let's get started. Alright, so this is where we left off last time. We started implementing the firing arrow mechanics, but it's still very basic and so many bugs that we have to fix. And of course, we are not even drawing the bow or pulling the string yet. So this is the first thing I want to do, which is when you hold the left mouse button, you pull the string, and then when you release, you fire the arrow. And depending on how long you pull the bow for, this is going to affect the speed and the gravity of the arrow. So the longer you hold the bow for, the better. So let's see how we can do that. First thing, let me ignore this fire arrow begin for now, and I'm going to create, let me create a variable first for is drawing bow. So this will tell me if I'm currently drawing the bow or not, and we need two custom events, one for draw bow begin, let me just call it draw begin, and another one for draw end. So draw just means pull the string, if you didn't know. And then let's start implementing the draw begin. What happens when we hold the left mouse button and keep holding it? Well, first thing, we want to set this variable we just created, is drawing bow, to true. And the reason is we want to check if we're already drawing the bow, then you can't draw it again, and you can only fire if you're drawing the bow. So this variable is going to prevent certain behavior from happening or not. So I'm going to start actually by checking if I'm already drawing the bow. So if get drawing bow is not true, so if I'm not drawing the bow, only then do I continue. That way, if you're holding the mouse button and then you try to hold it again, you have to end drawing first. And also let me add another condition. So I'm just going to pull off here and say and boolean. And we are aiming, so you need to be aiming to actually start drawing. So if you press the left mouse button, you're not aiming, then nothing happens. All right, so now we have our two conditions. Let's start. So the first thing we want to do is actually start a timer to tell us how long we've been drawing the bow for. So I am going to make a variable, call it draw time. So this is going to be the time that we're holding the bow for, and this is going to be a float. And as soon as we start, I'm going to set timer by event, and I'm going to set it to looping. And this event, let's just create a custom event here and call it increment draw time. So this timer is going to loop by a certain each few seconds or each few milliseconds. So I'm going to do it 30 times a second. So that's 1 divided by 30. And in case you didn't know, you can do mathematical operations here or in any input field, really. And I'm going to promote this to a variable. I'm going to call it the draw increment time. And what I want to do is every time this ticks, I'm going to get my draw time variable, and I'm going to set it with its current value plus the draw increment time, so how much time has passed. So that means every 0.3 seconds we add 0.3 or 0.03 to this variable. And then I'm just going to print it so that we can keep track of its value and see what it is. All right, now let's implement the draw end. So this is what happens when we finish drawing. And this could be for any reason. You maybe fired the bow, maybe you stopped aiming, whatever happens, we have to reset the state of the bow and the player. So first thing we have to set is, no, sorry, not this. Oh yeah, so this one is draw bow back to false. We want to set the draw time back to 0, so we reset it. And we also want to clear this timer. So we don't want the timer to keep running, we want to clear it. But we need it to be a variable to be able to clear it. So I'm going to right click, promote this to a variable, and call it the draw bow timer. And then I can get the draw bow timer here and say clear and invalidate timer. So this stops the timer from continuing to run. One more thing we can do as well is we want to set the state of the bow itself. So right now we're just setting some variables, but if you recall, when we aim, we set the bow to aiming state, and when we stop aiming, we set it back to idle. So we want to do the same thing here. So we want to get our bow ref, and when we draw begin, we want to set the bow states to draw, because remember, we already created this state in the enum. And when we are done, we want to set it back to idle. All right, so now let's continue with the fire arrow begin. So we're gonna keep this for now. Let's actually comment it and say draw bow, and we're gonna come back to it and add some things. But now let's do the fire arrow. The first thing you want to do when fire arrow begins is the same for drawing. We want to set a variable. So I'm going to create a new variable here, call it is firing arrow. And it should be a float, a Boolean. And I'm going to set it to true. And actually before that, we want to check if we are drawing the bow. Because you can't fire the arrow if you didn't draw the bow. So if you click and release somehow without drawing the bow, this will not fire. It's important to do these checks even though we know that you can't release the left mouse button without clicking it. So it's impossible to fire the arrow without drawing first. But it's also important to know that this component knows nothing about the player's input actions. It just knows that if you want to fire the bow, you have to be drawing. It doesn't make any assumptions on that the drawing the bow key is the same as firing the bow. So that's why these conditions are important, even though you might think it's a case that will never happen. All right, so after we do that, before we fire the bow, we also want to call draw end. So we stopped drawing the bow, so reset all the variables back. And then we want to fire the arrow. I'm actually going to convert this into a function. So I'm going to right click and collapse to a function and call it fire aimed arrow. And I'm going to call it here. And let's open up this function. So this we created last time. We just check if there is an arrow, we detach it from the actor, and then we get the forward vector of the camera and we fire it. One thing we actually forgot to do is reset the arrow ref. This is very important. So we set it back to nothing because we always check that because it's no longer the aimed arrow, it's just a fired arrow. So this way we can, this check will fail the next time if this is false. One thing we want to do now that we calculate the draw time, we want to add a strength input to this fire function. So this is the fire function on the arrow itself. If I open it up, we multiply by a random number of 1000 now, but we want this to depend on how long we've been holding the bow. And so we're going to add an input here, and we're going to call it strength. And this is just going to be a float value between 0 and 1. I'm not going to use it here yet, but I'm going to show you how we're going to use it in a bit. But let's actually calculate that strength variable first. So back in our bow mechanics, like we said, the strength is going to be a value between 0 and 1. And it's going to depend on how long we've been drawing the bow, but also what's the maximum draw time? So when do you reach the maximum? And we don't have a variable to tell us when we reach the maximum yet, But this variable should be on the bow itself, because maybe some bows you draw very fast. They're like weak bows with weak strings. Maybe some are more powerful, and so it takes a longer time to draw. So I think this should be a concern of the bow itself. So I'm going to go on my BP bow, and I'm going to add a variable here and call it max draw time. So when do you reach the max draw time? I'm going to just default it to 1 second. So after 1 second, the maximum is reached. All right. So to calculate this variable between 0 and 1, we have to get our draw time, and then we get our max draw time from the bow. And we want to normalize these two values. So I'm going to call a function called normalize to range between 0 and the max value. If you hover, this function will tell you that it normalizes to a given range. So if 20 is normalized to 10 and 50, it will result in 0.25, because 20 is 0.25 between 10 and 50. So basically what this does is it normalizes this value, whatever it is, to 0 and between 0 and 1. I know this is 1, but we don't want to make this assumption that it's 1, so it's always good to clamp it as well. So I'm going to call clamp float. So that means that if this value is ever more than 1, then just limit it to 1. That's what clamp does. And that will be our strength. So now we ensure it's always a value between 0 and 1, and the maximum is going to be maximum draw time. Now let's use this variable, like I told you. So in the arrow, we want to set the speed of the arrow as well as the gravity based on the strength. So we're going to create a few variables. One, we're going to call it the min speed. And that's going to be a float. And another one, we're going to call it the max speed. And also min gravity and max gravity. I'm not going to set values for them yet, but I'm just going to use the variables to show you. So right now we calculate the velocity by multiplying direction and speed, right? So this is what velocity is, direction multiplied by speed. So we want this to be our speed. But we have two speeds, right? We have the minimum speed and we have the maximum speed. So how do we pick between them based on strength? Well, the reason we made it a value between 0 and 1 is we can easily do something called a lerp, or linear interpolate. And what lerp does is it takes an alpha is a value between 0 and 1. And if it's 0, it picks A, and if it's 1, it picks B. And anything in between, it interpolates between. So that means that if the value is 0.5, then it will pick something halfway between min and max. And that's our speed. And we're going to do the same thing with gravity as well. So gravity is a variable on the projectile movement. So we're going to say set projectile gravity scale. And it's going to also, we're going to do a lerp node. And the alpha is our strength. Let me clean this up a little. And the min gravity is here, and the max gravity is here. All right, so let's put some values for these variables. So let's say the minimum speed, I have to compile. So let's say the minimum speed is 1,000. And the maximum speed is 3,000. And the minimum gravity is 0, no gravity. And max gravity, 1 is full gravity, but I think 1 is too much, so let's say 0.5. Oh, and this is actually not right. So when the strength is full, we want to use the minimum gravity. So when it's full strength, that means it's going to pick B. And that should be minimum gravity. And when the strength is not full, or is 0, then we want to pick the maximum gravity. That means gravity decreases the stronger you pull the bow, which makes physical sense. All right. And that is pretty much it for this fire arrow function for now. Now let's, in our AC bow mechanics, back in our fire arrow begin, let's also add a fire arrow, let's create a custom event and call it fire arrow end. So first thing we want to do is set is firing arrow back to false, and then we want to check, are we still aiming? So if is aiming is true, then let's call draw begin. So we keep drawing the bow. So you drew the bow, you fired. If you're still holding the right click button to aim, then we draw the bow again. And we need to call this function after fire arrow begin is over. So after the arrow is fired. We're going to have some animations, so we're going to actually call it when the animations are done. But for now, I'm just going to simulate that by adding a, say, 1 second delay and then calling fire arrow end in our fire arrow begin. Let me comment this and say fire arrow. Oh, and one thing I also forgot is we want, when we stop aiming, so on aim end, we want it, if we are drawing the bow, but we don't release it. We stop aiming, we need to end the draw as well. So on aim end, let's say here, let's call draw end as well. All right. And also let's comment these and say aim bow. All right, very nice. Now to be able to call these functions when we click or right click or whatever, we need to do this in our player on certain input actions. Last time we just simulated a left mouse button and we called fire arrow begin. We're going to delete that, of course, and do it properly with the input actions like we do for aim. So I'm just going to open up the folder where I have my input actions, and I'm going to right click and create a new one, new input action. And I'm going to call it input action underscore fire bow or fire arrow, whatever. So let's open this up. It's going to be a digital bool, and it's only going to have a single trigger, which is released. So that means it's triggered when we release whatever key we assign it to. So let's assign it to a key as well. So in our IMC default in our input folder, so this is our input mapping, we're going to create a new mapping for fire. And we are going to make it on left mouse button. And now back in our player, let's use it here. So I'm going to do IA fire bow. So on start, this is when we start holding the left mouse button. We want to get our AC bow mechanics and call draw begin. And on trigger or complete, whichever, both are fired at the same time, we want to call fire a bow. So this is when we stop holding or when we release the left mouse button. We're going to call fire arrow begin. Don't confuse it with fired aim arrow. This is the one that actually shoots the arrow. This one just is the function that begins the shooting the arrow, is the event that begins shooting the arrow. And we're going to call it on complete. All right, and now we want to test this out. Let me just comment it and say fire arrow or fire bow. Let's call it bow. Okay. Now let's test it out, and I'm gonna play. I'm aiming, and now I'm holding. You can see it printing, and any number above 1 is just going to be normalized back to 1. So it means just reach the max. And if I let go, actually that didn't look like 3000. Let's see what's happening. Something is wrong. We update the timer, and the timer seems to be updating correctly, but something in the firing arrow doesn't seem to be using correctly. So we get our draw time. Oh, I think I know what is happening. we call draw end before we call fire aimed arrow, and draw end resets the draw time. So very important to call fire arrow first before calling draw end. I think that's the problem. Let's try it again. And now I'm holding, reach the max. Yeah, there we go. And now that's a lot faster. Great. Now you can see there's still a problem when I fire and I'm still aiming. I don't have an arrow anymore. And I can keep firing multiple arrows very fast. If I just stop aiming and then aim again, I can ignore the delay or the limitation that's telling me I can't fire. So there are a few things we have to do to fix that. The first one to fix is pretty easy. We need to add another condition. You can't draw the bow if you are firing. So only if is firing is not true. And by the way, when I have a branch like this with a lot of conditions, what I like to do is convert it to a macro. So if I say collapse to macro and call this can draw bow, and let me show you how we're going to use the macro. So it's going to have, let me just clean this up. It's going to return 2 executables. So on the output here, you can add 2 executables, one called yes and one called no, and they are of type exec. So if it's true, it's yes. If it's false, it's no. And that way it's just cleaner and easier to read on the outside. So here it's like can draw bow, yes, can't, do whatever. You can do this for all your branches if you want it to be easily readable, but if it's only one condition like this, it's pretty easily readable like that. All right, so that should fix the problem of being able to fire. No, something is wrong. I can't fire again. Oh, this should be false. How did this become true? So on fire end, we set this firing arrow to false. Don't know how that became true, but yeah. But now I have to wait the full 1 second before firing again. But there is something else. We are still not aiming the arrow again. After shooting one, we don't get a new one. So let's fix that. I think the problem here is actually I made a mistake. When fire arrow ends, I call draw begin if we're aiming. I shouldn't be calling draw begin. I should be calling aim begin. Because if you remember, we stop aiming when we fire the arrow. So because we stop drawing. So we need to call aim begin again, and that's the one that spawns the arrow. So now if I do this and I shoot, 1 second later, I have another arrow. Perfect. And if I just click, it goes slow. And if I click and hold, it goes fast. But as you can see, we don't have any animations for when I pull the bow. And when I stop, it just goes back in a very awkward place. So let's add some animations. So I already have animations for my player, draw bow, draw full. And it just looks like this. It slowly pulls the bow from the aim point until the fully drawn point. And I also have it for my bow animations, draw half to full. And these two are synced together, and their duration is the max draw time of the bow. So when everything is put together, it will look perfect, and the timing will also be when you reach the end, then it's fully drawn. So let's start with the player. We're going to open up ABP player, and we're going to create a new variable. So we have is aiming here that we get from our AC bow mechanics. We also need to get is drawing bow. So if is, get is drawing bow, promote that to a variable with the same name, is drawing bow. And then in our animation graph, we created the upper body states, if you recall. And drawing bow is also an upper body only state because you can draw the bow and move at the same time. So we're going to open this up, and right now we only have aiming. We're going to create a new state, so add state, and call it drawing. And inside this, it's just going to be our draw bow full. But we need some transitions, so we need to go from aiming to drawing and drawing back to aiming. So from aiming to drawing, the condition is if is drawing bow is true, and the other way around, if is drawing bow is not true. All right, let's test this out. So now I'm pulling, and yeah, nice. So the animation works pretty well. And the bow, of course, is not animating yet. So I'm pulling, and the string is not coming with me. So let's do that next. So in our ABP bow now, let me minimize this. I don't know why it's so large. So in ABP bow, we don't need a variable because we already have bow state here as a variable. So we're going to open our main states. And now we are going to create a new state as well and call it drawing as well. Open it up and draw half to full. This is the animation. Make sure none of these are looping because we don't want them to loop, of course. And here we're going to have transitions back to idle and back to aiming as well. So you can go in either state. So to idle and back is the same. So if this one is from drawing to idle, if the bow state is equal, make sure you use equal enum to idle, then you go back to idle. And here, if it is equal to draw, then no, draw, then you can enter draw. Same thing here. So from idle, you can't really go from idle to drawing. You have to aim first, but let's assume you can. It's just going to be this condition if bow state is equal to draw. And from drawing back to idle, that can happen if bow state is equal to idle. All right, I think now we have all these set up. Let's see how it all looks like. I'm aiming and pulling, and nice. The string is pulled with my hand at the same time. The only things missing now are actually the firing animations. So when I let go of the bow, we don't have an animation for the player, and also the bow just looks pretty awkward in that middle position. So let's fix that. So I already have in my player an animation for firing the bow fire. Yeah, looks like this. But we want to make it into a montage because we are going to play it. It's not an animation state, it's an action, and actions should usually be montages. So I'm going to right click it and simply say create anim montage, call it montage fire bow. And then in my AC bow mechanics, I remember when I told you here in the fire arrow begin, we just do a delay and then we end the fire arrow. Here we're not going to do a delay anymore. We're going to play that montage. So before firing arrow, we want to play montage in our skeletal mesh, which we can get by getting our character and getting the mesh. That a bit. So we have our character, we have our mesh, but right now I don't want to just plug in this montage here because remember, this is an actor component. It should be a modular and reusable thing. It shouldn't make assumptions on what variables to use. So this should be a variable and called the fire bow montage. And the person, or class that's using this actor component, which is our BP player, should click on it and set the fire bow montage. So the player knows what montages or animations they want to use. So then the player is responsible. So you can take this component, put it on another character in another project, and just change the variables. All right. So now we call fire end when we complete or we are interrupted for any reason. And this animation roughly takes a second, so you can only fire an arrow once every second. All right, let's try it again. And we release, we fire. Great. Right now, there's still a bug we need to fix with the montage itself. And the montage, if I play it while I'm moving, you see that it doesn't blend with the lower body. So my feet stop moving when the montage is playing. So it's playing the full animation. I only want the montage to play the upper body parts and not the lower body parts so that I can continue to move and jump while still doing the fire animation. So how do we do that? Well, if I go to the montage itself that we're playing, which is this one, the montage fire bow, what you can do is you can tell it which slot to play in. So right now it's by default going to be the default slot. So I can say slot name and pick one of these. These are all slots configured on the mannequin. If you have your own character, you might have to create a new slot first and name it upper body. But for now, I'm going to pick the upper body slot. When you do that, the animation will stop working. Don't worry about that. If you just go to something else and come back, it will work fine. Here in the preview, you won't see any difference. You're just telling it that when this animation plays, it should play in a slot called default slot in your animation blueprint. I don't have that slot right now in my animation blueprint, so if I do play, nothing happens. I'm not playing the fire animation at all. That is because in the ABP player, here in the anim graph, we only have default slot. We don't have any other slots for montages to play. So we're going to create a new one, an upper body slot, but we're not just going to add it here. Remember, we have our upper body state machine here, so we're going to add it just after this. I'm going to copy this default slot and paste it here. Then I'm going to go on the slot name and rename it to upper body. And I am going to add it after our regular upper body state machine. Now if I play, the fire happens and it's only blending with the upper body, so my legs continue to move while I fire. Now this is great because we've set up this upper body to always blend with the spine depending on whether we're aiming or not. So this is really helping us implement any upper body animation without having to continuously do this blend multiple times. Now that we're still on the topic of animations, there's still a glaring issue with the animation you might have noticed. That when I move the camera up and down, which is basically I'm aiming up and down, the character itself doesn't move up and down with me. So the mesh keeps aiming in the middle. So I can do this and shoot down, and the arrow goes straight down. And same if I do this and shoot up, the arrow goes straight up, but the bow is not looking up. So this is obviously a mistake, and we have to fix that. Now, the way this works is we create something called aim offsets. And aim offsets, they take the pitch aim of your character and modify the animation or add an additive animation depending on what the pitch is. All right, so what we want to do is have a base pose for our aim offset, and that's going to be our bow aim animation. First, I'm going to duplicate it. I'm going to create a new one, and I'm going to call it AO for aim offset, bow middle. Middle because we're going to be aiming in the middle and up and down. That's how we create our aim offset blend. And also let me create a new folder called AO for aim offset and put that one in it. But what we want is this to be a pose, not a full animation. So we want it to be a single frame. And more specifically, we want it to be the last frame, this one. So I'm going to delete, this is frame 11, you can see here. I'm going to delete frames 0 to 10. So I can just right click here. And if you right click in the beginning, you'll see delete frame 0 to 6. If I right click more towards the end, it's going to say frame 0 to 9. So right clicking here, yeah, it's going to give me remove frame 0 to 10. And I'm going to do that. Now I have a single frame animation. If it looks jittery like this, don't worry about it. We're going to use it as a pose anyway, but you can also try to do it again. Say remove frame 0 to 10. Yeah, now it's fine. Sometimes it does that. I'm not really sure why. But anyway, now that we have this single pose, I'm going to duplicate it 3 times. Like I said, we're going to have one for middle, one for aiming up, and one for aiming down. We're only going to do pitch, by the way. Sometimes you can have an aim offset that does 360 rotation or 180, depending on how your character moves. But we're only doing up and down because our full character rotates left and right. So the yaw is already covered. So let's see how we're going to do this. First of all, this is going to be an additive animation. It means it's going to add on top of what's already playing. So to do that, we're going to go down to our additive settings here and change it to mesh space. That means that we're going to create an additive animation on the space of the mesh and not local space. And it's going to ask us for a base pose type. Here we're going to say selected animation frame. So select an animation, a frame from this animation. And we're going to use the middle pose, so this basic pose, as the base pose type for all 3 aim offsets, up, down, and middle. So now this is an aim offset for aiming in the middle, which is our default aim position. Now let's open up aim up. And we're going to do the same thing, also mesh space under additive, selected animation frame, and select AO bow middle. Now, what we want now is to modify the skeleton of this pose to aim up 90 degrees. So what I'm going to do is I'm going to rotate spine 4 and spine 3, each by 45 degrees to be aiming up 90 degrees. Now, I can rotate a single spine 90 degrees, but it just looks a bit awkward. So I like rotating multiple spines. It's more realistic because when you move, you don't move a single bone. You kind of move multiple ones. So let's see how that looks like. First, make sure you are on the 0 frame if you have multiple. And I'm going to rotate this 45 degrees. And then I'm going to click key here to save this bone transform. Then I'm going to go on spine 3, do the same thing, rotate 45 degrees, and press key. Great. Now our animation is saved at this pose. I'm going to do the same thing for down, but instead of rotating up, I'm going to rotate down. So spine 4, rotate down 45 degrees, and key. Spine 3, rotate down 45 degrees, and key. Great. Now we have our 3 positions. We need an aim offset blend that blends between them, depending on where we're aiming, our pitch. So to do that, we're going to right click here and search for something called aim offset. Now we're going to create a 1D aim offset. Like I mentioned, we're only doing pitch, not yaw or roll. And we're going to do it on the SK mannequin skeleton, and I'm going to call it AO bow. Open it up. Under asset details, we have a single axis. Now we need to tell it what this axis is. It's the pitch. It means where we're aiming up and down. And it's between -90 and 90. And the grid only has 2 divisions because we have only 3 animations, middle, up, and down. And then here we want to get these animations. Middle goes in the middle where pitch is 0. Up goes at the end where pitch is 90. And down goes -90. Oh, down. Oh, the down doesn't want to... Oh, did we not make this an additive animation? Oh, we forgot to add additive here. Yeah, this is very important. Mesh space, selected frame, middle. You can only add additive animations in an aim offset. That's why it wasn't letting me do it. Now, down is working. Now, you're not going to see anything yet. So when you press Control and move, you're moving along this line. But you're not going to see anything until you add a preview pose. So I can do the aim pose, for example, and then I can preview it. So as you can see here, let me stop it at the end. So it's going to look something like this as we are aiming up and down. Nice. Now this is just a preview pose to see it in the window. It doesn't actually do anything to the aim animation. Now we need to use this aim offset blended with our upper body. So back to our ABP player where we blend everything upper body related. Just at the end here, I am going to search for this aim offset AO bow, and I'm going to add it right here and plug in the base pose. Now, we're only missing one thing, the value for pitch. Now, how do we get that? So in our event graph here, how we get the pitch, depending on where we're aiming, is by doing the following. First, I'm going to get my character, and I'm going to get something called get base aim rotation. Now, this gets the rotation of the controller. So basically, if you have a controller, which is in this case our camera, where the player is currently looking, not where the mesh is looking. That's very important. But then we get also the mesh's rotation. So then we get actor rotation. We need both. And we get the delta, or the difference between them. So to do that, there's something called a delta rotator that takes in 2 rotations and gives you 1 rotation back, the difference between both. And the difference between both, we're going to split it. We only want the pitch. So then we right-click, promote this to a variable, and call it pitch. And just like that, we have the pitch variable. Let's add a pin here and plug it in. And let's comment this and call it pitch. All right, now that we have pitch back in our aim graph, let's just get our pitch that we just created. Nice. So let's test it and see if everything's working. I'm aiming, and nice. As you can see, now the mesh is pointing where our camera is actually aiming. Very nice. And this blends with all of the animations, upper body, lower body, everything is working very nicely. All right, now let's move from animations to something else for a little bit. And that's creating our crosshair widget, our aiming widget. Because right now, we don't really see where we're aiming. Where is this arrow going to go when I'm going to shoot it? I don't know. So we need to add a crosshair in the center of the screen. So let's do that. Open up the contents folder. I already created a widgets folder here that only has a single image. And this is a white circle. It's a very basic image. You can create a white circle in any program really. But my crosshair is going to be a circle with a dot inside. And eventually we're going to make it dynamic as well. But let's just create the widgets. So in my widgets folder here, right click and search for widget blueprint of type user widget. And we're going to call it w_crosshair. Open it up. It's going to have, let me close some of this. Let's keep those. Okay. First of all, it's going to have a canvas panel. And this canvas panel can be any size, really, doesn't really matter. Because everything we're going to put in there is going to size to the content. And it's going to have an image. This image, I want it anchored in the center and then reset its position values. And yeah, size doesn't matter. We're going to say size to content. And what we want inside here is the, where is it? So brush under image, we want to select this white circle. Yeah, right there. Obviously, this is way too big. All right, so I accidentally moved the anchor point. All right, and we want it in the center of the anchor point. So alignment will be 0.5, 0.5. Now, I want a dot inside the circle. So I'm gonna get, let me just call this the outer circle. And let's get another image in here. And let's call this the dot. This is also going to be anchored in the center. Reset position values. Size doesn't matter. Alignment 0.5, 0.5, and size to content. Now the image size here matters. It's just going to be a 3x3 image, so little dot, and the draw as rounded box. That's what makes it a dot. So I don't need an image for a dot. You can create a dot out of the basic image shape. All right, and this is our crosshair widget. Now, I'm not going to add this widget directly to the player. I'm first going to create another player HUD widget, and then the player HUD is what's going to add this crosshair. And it's good to compose your widgets so to make them a bit more structured. So right-click, new widget, call it of type user widget, and call it w_player HUD. It's also going to have a canvas panel, and it's only going to have one thing here, which is the crosshair widget. So you can just drag and drop the widget here. The widget, did I not compile it? You should compile it. Okay, now that it's compiled, you can see it. Now the widget, I want it to be a specific size here. Here the size matters. First of all, I'm going to center it. And again, 0.5, 0.5. And let's say the size is 44 by 44. That's going to be my widget, and this whole thing is going to be my HUD. Now, let's also say this is a... Yeah, it doesn't really matter for now. Let me just display it on the player, and we'll see how it looks like. So, back to my BP player. I'm going to create a function. Let's create it here in the top. I'm going to create a function, custom event called create HUD. And this is going to call create widget of type player HUD. And it's just going to promote that to a variable. So we have a reference to it, player HUD ref, in case we need to do anything. And then calls active viewport. All right, so now we have a HUD, which stands for heads up display, in case you didn't know. And then we want to add it on begin play here. Actually, to make this a bit clean, also let's move these to a separate function. Let's call this init variables. So these are just the initial variables that we created. I don't want them to be directly in the begin play. Init variables. So that way I can over here just call initialize variables and create HUD. Yeah, that's a lot cleaner now. All right. So let's see what this looks like when I play. There is a HUD in the center of my screen, but it's always visible. I want it only to appear when I aim and disappear when I stop aiming. So how do we do that? The way we're going to do it is we're going to fire an event from the player, or technically from the AC bow mechanics, that the player started aiming. And then when the player stops aiming, we're going to fire another event. And then in the widget, we're going to listen to these two events. When the player starts aiming, show the widget. When the player stops aiming, hide it. So firing an event in Blueprints is done by creating event dispatchers. So here on the side, I'm going to create two event dispatchers. Call this on aim begin, and another one called on aim end. Usually when you name events, you name them with on something because it's a signal that something happened. And then I'm just going to call here on aim begin, say call. So I'm calling on aim begin here in the aim begin, and on aim end, call it here. So now we're firing these events and we can listen to them from anywhere. So in our HUD, I'm not going to do it in the crosshair. I'm going to do it in the HUD because the player is the ones responsible for doing this. So I'm going to go to my graph tab here, and I need to listen to these two events. And to listen to the events that are fired from somewhere, I need a reference to the class that's firing these events or triggering the event dispatchers. So let me delete the tick. Let me delete the pre-construct. So on construct here, I'm going to get the owning player pawn. This is a reference to the pawn that spawns this widget. And in this player pawn, I'm going to check, do they have the AC bow mechanics component? Because if they don't, then nothing really has to be done. So get component by class, and I'm going to search for AC bow mechanics. Then if this is valid, So if is valid, use the one with the question mark. That's a macro. So if this is valid, that means that the person spawning this player HUD has AC bow mechanics. So let's give them the functionality of only showing it when we aim. So first thing we want to do is get our crosshair and hide it. So the default visibility, set visibility, is collapsed. So that's the default. Now we want to listen to these two events. So we get a reference to our AC bow mechanics, and we say assign on, and then the name of the event. Assign, what it does is binds and creates an event. Or you can also say bind on event, bind on aim begin, and then create the custom event yourself. So let's say custom event, and we'll call it show crosshair. All right, so when this event is fired, here we're just binding the event, and here we're saying what happens when it's triggered. So when it's triggered, get the crosshair and set the visibility to visible. Now we need to bind again when the visibility, when we stop aiming. So we're gonna pull off of this again and say, this time let's do the assign on aim end. So you see it automatically created a event for me. I'm gonna call it hide crosshair and move it here a bit. So and here all we're gonna do is we're gonna get this and we'll set the visibility to collapsed again. All right. Now this should work. Hidden by default, I aim visible. Great. Now, one final thing I want to do is calculate the correct trajectory of the arrow, or the direction. Right now, you'll notice the direction is not correct, and let me show you. So I'm gonna aim, I don't know, let's say right in this top left square here. And as soon as I fire the bow, you see that it's going somewhere else. It's not going where I'm aiming. You see that? So I'm gonna aim here. Oh, that was too weak. Aim right here in the center. And it's going to the left. Now, the reason is we're not calculating the aim direction correctly. In our AC bow mechanics here, if we go to our fire aimed arrow function, what we do is we just get the forward vector of the camera, and that's our direction. And that's not really correct. What we want is to trace from the camera to, let's say, a few thousand units forward and see where it hits. And that's our end location that we want the arrow to go to. So let's see how we're going to do that. First, I'm going to select these and I'm going to create a function out of them. So collapse the function. I'm going to call it calculate aim direction. All right, and now we have a function that returns a single value, and I'm going to call this value direction. Now, inside this function, we are going to use the camera's forward vector, but we're going to do a lot of other things as well. So what we want is to get the forward vector of the camera and multiply it by a float value. So convert this to a float. And let's say a very long value. Let's say 10,000 units away. All right, so this is how far we can aim. And then we need to get our character and get the actor location. And we're gonna add this forward vector to our actor location. So when you add a forward vector to when you add a direction to another magnitude vector, you get a direction and length. So in this case, when I do plus here, I add these two. Let's make this the top one, this the bottom one. Now I have where this line ends. So it starts from the forward vector of the camera, ends 10,000 units away from where the player is currently starting. And I'm going to do a line trace. So line trace by channel. Let's do the visibility channel. And the start, we start where the camera is. So oh, actually, sorry, this shouldn't be the actor location. This should be the camera's location. So get world location. That's my bad. So we start where the world location of the camera is. Let me also invert the order of this to make it a bit cleaner, because we're going to use the world location on top. So we start the trace where the camera currently is, and we end the trace 10,000 units in the direction where the camera is facing. All right, and I'm going to make this drawn persistently so we can see it. And right now, let me, I'm not going to return anything. I want to just show you the trace. So I'm looking here and I fire, and there's a line drawn from here to where the camera was pointing. Great, and it stretches out 10,000 units. Now, how do we get the direction based on this line? Because this line is obviously aiming correctly. So what we want to do is we want to check first if we hit something or not. So if we did hit something, so let's break our out hit. If we did hit something, our hit location is the end of the trace. And this is where we want to get the direction from. So we are going to calculate direction by calling get unit direction. So this takes in two vectors or two locations and gives you a direction based on them. So the two locations is where the arrow is starting and where we want the arrow to end, and give me the direction the arrow needs to travel to go from its current point to the end point. Now the end point is going to be location if there's a hit, but it's going to be trace end if there is no hit, because then this is not a valid location. Instead of doing a branch and checking if there's a hit or not, you can do this easily by creating a select node. So if Boolean is true, and Boolean is this one, if there is a hit, then pick A. So if there's a hit, pick location. If it's false, no hit, pick trace end, which is B. All right. And the from location is where our arrow currently is. So we need to get a reference to our arrow. Let's make sure it's valid in case something is wrong with the arrow and we're trying to fire an arrow that doesn't exist. So only if it is valid, get the actor location. All right. So now we're checking where the arrow is starting versus where it should end based on a trace, and get me that location. Let's test it out. And I'm going to fire right here. Nice. As you can see, the arrow goes right to my trace. And that's how you calculate the correct location. You can draw persist this back to none. Excellent. And that's it for part 3. We've got a lot done. We fixed our firing mechanics, we added the crosshair, we fixed our direction, we added aim offsets, aim animations, shooting animations. It was really packed. I'm very happy with this one. And coming up next, we're going to start adding some sound effects, visual effects to our arrows and to our bow to really bring life into this mechanic. So, as always, thank you all for watching, and I'll see you in the next one.